Good morning students, this is Latif sir. In this video today I'll discuss how to represent a chemical compounds. How to represent a chemical compounds. So representation of a chemical compounds. Okay. So to represent a chemical compounds using the symbol of each element present in the compound, present in the molecule, you have to follow some rules. Okay. Here are some step or rules you have to follow to write down the chemical formula of a compound. Okay, there are 4 steps are given. Let us explain how to write, how to represent the chemical formula of a compound. Okay, with an example. For example is write chemical formula of iron 3 carbonate. Iron, or simple example, I am taking simple example, zinc chloride. Okay, so in zinc chloride, Zn as a cation is present, Zn2 plus, and chloride Cl minus ion is present. Okay, first you have to write the symbol of each element present in the compound. Okay, then you have to write their valency. Valency of zinc is 2, valency of chlorine is 1, just below them, below the symbol of each element present in the compound. So in zinc chloride, zinc cation and chloride anion are present. So first you have to write the formula, you have to write the symbol of cation and then anion. Then you have to write the valency just below their symbol, and in next step you have to exchange their valency of zinc you have to exchange with chlorine, and valency of chlorine you have to exchange with Zn, zinc. Okay, and after exchanging valency you have to write as a subscript. Okay, so Zn1 and Cl2. Okay, now we have to check whether there is any common factor of these valencies after exchanging. So it becomes Zn1 and 2. So there is any common factor of 1 or 1 and 2. If there is any common factor, then you have to divide both these valencies by the common factor. If there is no common factor, then you have to write directly, you have to join them. Okay, and if this number is 1, it is not required to write down. Okay, so the chemical formula of zinc chloride is ZnCl2. Okay, one more example I am giving here. Write the chemical formula of iron 3 carbonate. Iron 3 carbonate. Iron 3 means in iron 3 carbonate, as a cation Fe is present, Fe3 plus, and carbonate means CO3 2 minus. So first you have to write the symbol and chemical formula of cation and anion, and then you have to write their valency. Iron 3 means valency is 3, and carbonate means valency is 2. So after this step you have to exchange the valency. Okay, so after exchanging valency it becomes Fe2 and CO3. As CO3 is a polyatomic ion or radical, you have to write the CO3, the formula of CO3 within bracket. So after exchanging the valency it becomes Fe2 and CO3, Fe2 and CO3 whole thrice, CO3 whole thrice. Now check there is any common factor of 2 and 3. 2 and 3, there is no common factor of 2 and 3. If there is no common factor, then just join together and write them as a single unit. So the formula of iron 3 carbonate becomes Fe2CO3 whole thrice, Fe2CO3 whole thrice. Okay, it is the chemical formula of iron 3 carbonate. And next example is given. Write the chemical formula of calcium hydroxide. So in calcium hydroxide, as a cation calcium 2 plus and as anion hydroxide are present. So calcium 2 plus, so valency of calcium is 2, and hydroxide means OH minus, so valency of hydroxide ion is 1. Okay, so valency of in next step you have to write the valency just below the symbol. In next step we have to exchange their valency. As OH is a polyatomic ion, you have to give a bracket. So after exchanging valency you have to write the valencies as a subscript. Ca2OH whole 1. Okay, and have told that if this number is 1, it is not required to write down. Now see, there is any common factor of 2 and 1. There is no common factor of 2 and 1, so just you have to join together Ca and hydroxide ion. Okay, and the formula of calcium hydroxide, sorry, it is hydroxide 2 and calcium 1. It is mistake. So after exchanging valency, it becomes Ca1 and calcium 2, not the calcium 2 and hydroxide 1. So again I am writing calcium 2 and hydroxide valency of hydroxide ion is 1. So after exchanging valency, it becomes Ca1 and hydroxide 2 whole twice. Now see, there is any common factor of 1 and 2. There is no common factor, so just you have to join together. And this is 1, so it is not required to write down. So CaOH whole twice will be the chemical formula of calcium hydroxide. So using this basic 4 step, you can write down the chemical formula of the compound. Okay. Now see, next topic, significance of valency. First you have to know what is the valency. In simple word, valency is the combining capacity or combining power of an element. Valency is the combining power of an element. You can express valency of an element in different ways, in terms of number of hydrogen atom, in terms of number of electrons, valence shell electrons. Okay, so in terms of number of, so valency means the combining power of an element, and in terms of number of hydrogen atom, in terms of number of hydrogen atoms, valency can be defined as the number of hydrogen atoms that can combine with one atom of an element, okay, forming a compound with hydrogen. For example, in methane means Ch4. In methane, carbon is directly attached with 4 hydrogens. So 4 hydrogen atoms are joined with one carbon atom. So in methane, valency of carbon is 4. Similarly, in water in H2O, one oxygen is attached with 2 hydrogens. So valency of oxygen is 2. Okay, so valency is equal to number of hydrogen atoms directly attached with the with one atom of that element. Okay, so now see, valency based on hydrogen atom. I have told that valency is equal to number of hydrogen atom. So the number of hydrogen atoms that combine or replace one atom of the element or radical to form a compound is equal to the valency of that element. In a cell, one hydrogen atom is directly joined with one chlorine atom. So valency of chlorine is 1. In NO3, the valency of nitrate ion, valency of NO3 minus ion is 1, because NO3 minus ion is directly joined with one hydrogen atom. Okay, so valency of nitrate NO3 minus ion is 1. Here some example, number of hydrogen atoms and their valency in this table 4.6. It is showing number of hydrogen atoms and valency. So some compounds, water I have told, in water 2 hydrogen atoms combine with one oxygen atom, so valency of oxygen is 2. In ammonia, 3 hydrogen atoms combine with one nitrogen atom, so valency of nitrogen is 3. In sulfuric acid, 2 hydrogen atoms are combined with one sulfate radical, so valency of sulfate radical is 2 in H2SO4. Now next topic is periodic table. What is periodic table? It is a periodic table. Here it is showing 4.5, figure 4.5, modern periodic table. So what is the periodic table? It is the representation or arrangement of all the elements in a tabular form. The periodic table is an arrangement of all the elements in a tabular format, and it has 118 elements. In the periodic table, there are some vertical column and horizontal rows, and the vertical columns are known as group, and the horizontal rows are known as period. In the periodic table, each box contains one element. Each box there are 118 elements, and these vertical columns are known as, from top to bottom, these vertical columns are known as group, and the horizontal rows from left to right, these are known as periods. In this modern periodic table, there are total 118 elements, and these 118 elements are arranged in 18 groups and 7 period. There are total 7 period and 18 groups. Okay, so the elements are arranged in the increasing order of their atomic number. The periodic table has 18 vertical columns, and these are known as groups, and the group numbers are represented like this, 1 to 18, and there are 7 horizontal rows, and these are known as periods. Okay, this is the modern periodic table. Now see here, one important point is given. The group of the periodic table are arranged such that all the elements within the same group share similar property. The groups of the periodic tables are arranged such that all the elements within the same group share similar property. For example, element of calcium and magnesium belong to group 2. Thus, the number of valence electron of calcium and magnesium is same, and that is, it is 2. Okay, and you can tell valency of an element with the help of number of electron in the valence shell of an atom. Valence shell means outermost shell of an atom. Okay, so valence shell means outermost shell of an atom. You know, in an atom, the protons and neutrons are present at the center of the atom, and this is known as nucleus. The center of the atom is known as nucleus, and the electrons are revolving around the nucleus in different circular path, and these are known as shell. Okay, so electrons are revolving in different circular path, and these are known as these circular paths are known as shell. Okay, and the number of protons present at the center of an atom, that is at the nucleus of an atom, is known as atomic number. The number of protons in an atom of an element is called its atomic number, and protons are present in the nucleus of an atom. Okay, and electrons are revolving around different circular path, and these are known as orbit or shell. Okay, and the outermost shell of an atom is known as valence shell. Okay, so you can also tell the valency, or you can also calculate the valency of an atom in terms of number of electrons in the valence shell of that atom. Okay, the valency of an atom of an element is equal to the number of electron in the valence shell of an atom of an element is equal to the number of electron in the valence shell, or if that number is 4 or less. Otherwise, if the number of electron in the valence shell is equal to 4 or more than 4, then you can calculate valency using this formula, that is, valency is equal to 8 minus number of electron in the valence shell. In the valence shell, when number of electron is more than 4. Okay, so if number of electron in the valence shell is more than 4, then valency is equal to 8 minus number of electron in the valence shell. But if the number of electron in the valence shell of an atom is 1, 2 or 3, then valency is equal to number of electron in the valence shell. Okay, in table 4.7 it is showing valency of different element. Okay, based on valency based on number of electrons, valency based on number of hydrogen, valency based on valence electron. Okay, in all that cases you can see from group number 1 to group number 1 to 18, valency first increases from group 1 to group 14, that is 1 to 4. Then group 15 to 18, then group 15 to 18, valency again decreases from 3 to 0. Okay, from group 1 to group 14, valency increases from 1 to 4, and then from group 15 to 18, valency decreases from 4, 3, 2, 1, 0, like this. Okay, so 4 to 0. And this chapter is completed. Thank you, students.